Hello students, very good afternoon. This is Mayur S. More, your chemistry tutor. I welcome you all to the NEET Crash Course. Okay, as you all know, the NEET exam has been scheduled. As you all know, the NEET exam has been scheduled on 12th of September, right? So on the grounds of that, practically has brought exclusive a NEET Crash Course for you. And we have already reached to the 17th session of NEET Crash Course. We have already finished the 16th session. Today we are into the 17th session of our NEET Crash Course. And today we're gonna cover again the two very important chapter, one from your physical chemistry and another is from the what I would say bioorganic chemistry. So one is chemical kinetics, another is biomolecules. Okay, so okay, that's it for today. So let's begin. So Shashikala Jaiswal, it has started. Okay, so very good afternoon everyone. So let's begin. Very first question. In the reaction, involving the synthesis of ammonia, by Haber's process, N2 reacts with 3H2 to gives you 2NH3. The rate of reaction was measured as 2.5 into 10 raised to minus 4 mole per liter per second. The rate of change of concentration, of H2 will be. Now let me tell you how all of these are actually connected. Okay, so the rate of change of all of this. So if you see the minus d of N2 divided by dt is equal to minus 1 by 3 d of H2 divided by dt. Why we are putting a negative sign? Because concentration of reactant is decreasing. Okay, then plus 1 by 2 d of NH3 divided by dt. All of this is equal to rate of your reaction R, right, which is already given. What they have asked, the rate of change of concentration of H2. The rate of change of concentration of H2 will be equal to R minus 1 by 3 d of H2 divided by dt. R is given to you. R is 2.5 into 10 raised to minus 4 is equal to minus 1 by 3 d of H2 dt. Sending 3 to that side, what do we get? 2.5 into 10 raised to minus 4 into 3 is equal to minus d of H2 divided by dt. 2.5 into 3 is equal to 7.5 into 10 raised to minus 4. And that is equal to rate of change in concentration of your hydrogen. That is why the answer in this particular case is 7.5 into 10 raised to minus 4 mole per liter per second. That is why option C is our correct answer in this case. Okay, we all know, we had seen all of this. We are only summarizing all of this. Okay, chalo, moving ahead. Next, in the formation of sulfur trioxide, by contact process, 2SO2 reacts with O2 to give you 2SO3. The rate of reaction was measured as 2.5 into 10 raised to minus 4 mole per liter per second. The rate of reaction expressed in terms of SO3 is. How can we calculate it? Again, the rate of your reaction R is equal to minus 1 by 2 change in concentration of SO2 divided by dt. Why I have put 2 here? This 2 is equal to stoichiometric coefficient. It is equal to stoichiometric coefficient, which I'm really sure that you must have studied in your 2 years. So you already know all of this, right? Is equal to minus d of O2 divided by dt is equal to plus 1 by 2 d of SO3 divided by dt. They are asking for SO3 only, right? So R is equal to plus 1 by 2 d of SO3 divided by dt. So 2 was that side. R is equal to 2.5 into 10 raised to minus 4 into 2 is equal to rate of change in concentration of SO3 divided by dt. 2.5 into 2, that becomes how much? 5. 5 into 10 raised to minus 4 is equal to change in concentration of SO3 divided by dt. So that is why the answer is 5 into 10 raised to minus 4 mole per liter per second. That is why in this case option is D. Okay. Sure. Moving ahead, the rate constant of a reaction is equal to rate of reaction. Now rate constant is equal to your what? This is your R. R is what? Rate of reaction. Rate of reaction R is equal to K. And suppose in your reaction A plus B are reacting to give you C plus D, right? So that means A and B are your reactant. So R is equal to K, A raised to M, B raised to N. Okay, we don't know the values of M and N, so I just took the random number M and N. So R is equal to what? Rate of reaction. K is what? Rate constant. Now you also know when can R is equal to K. When rate of reaction would be equal to rate constant, when your M is equal to 1, not actually 1, yes, you can say when concentration of reactant do not change with time. Not only that, also when concentration of all reactant products are equal at time t is equal to 0, when concentration of all reactants are unity. Concentration of all reactant, that means this concentration. If this concentration is unity 1 and B also 1, then if A is equal to 1, B is equal to 1, what will happen? 1 raised to, you take any number, your M could be any number, 1 raised to anything will always be equal to 1. So in that case, K into 1 will be equal to R is equal to K only. And when this can happen? This can happen when concentrations of all reactants are unity. When the concentration of all reactants are unity, then rate of reaction is always equal to rate constant. Okay, I hope you must have known with all of this. My job is only make you remind all of this, since we are preparing for the exam of NEET exam, right, which is going to come on 12th of September. Okay, sure. Moving ahead, next question. If the concentration of reactants in the reaction, which reaction? It is given to you, 2A plus B gives you AC plus D, is increased by 3 folds. If the concentration of reactants in the reaction is increased by 3 folds, the rate of reaction will be increased by how many folds? Now we don't know the rate equation for this reaction, but when we don't know the rate equation, then always remember this stoichiometric coefficient N is your order. So as far as A, it is 2. As far as B, it's 1, right? So R is equal to K, A raised to 2, B raised to 1. Okay, now concentration. Now what they're saying, concentration of reactants and in the reaction is increased by 3 folds. Now 3 fold means what? K is equal to what? 3x, just in case. Okay, 3x square. If initial concentration of A is x and B is equal to y, then 3-fold means it becomes 3x and B is y, so that y becomes 3y, right? So R is equal to K, 3x square. 3 square is 9, 9x square, and 9 into 3y. So is equal to K, 9 into 3, 27. So that means when the concentration of reactant is increased by 3 folds in this particular reaction, the rate of reaction increases by a fold of 27. That is why the rate of reaction is increased by 27 times in this particular case. Okay, that is why our answer here is 27, option A. Okay, next, the rate of change in concentration. the rate of change in concentration of C in the reaction 2A plus B 2C plus D was reported as 1 mole per liter per second. The rate of change in concentration of C in the reaction was reported as 1 mole per liter per second. Calculate the reaction rate. Now again, how can we calculate the reaction rate here? Or I would say rate of reaction R. As far as they are concerned about what? C only, right? The rate of change in concentration of C. They have given us rate of change in concentration of C. From that, you need to calculate the rate. So as we all know, we had seen with the two numericals already in the first and second slide, the rate of this reaction as far as C is concerned would be equal to plus 1 by 2 rate of change in concentration of C divided by dt. So dC by dt is what? dC by dt is rate of change in concentration, which is 1 mole per liter. So half into 1. Half into 1 is equal to how much? 0.5. 0.5 mole per liter per second. And that is why in this case our answer is 0.5 mole per liter per second, which makes option C to be correct option. Okay, that's how you can solve this kind of question. These are not that difficult questions. Okay, these questions are quite easy. But the fact that, as I told you earlier, maybe in the yesterday only I told you that you are preparing for NEET exam. And NEET exam, that means medical exam. So you won't be needing a mathematics that much. So therefore, question which has been asked to you won't be having that much mathematical angle. Okay, it will be simply, but yeah, there will be some tricks with it always. Okay, so moving ahead. So I hope you are really enjoying this session. If you really do, please like, comment, and subscribe to Practically on YouTube. Yeah. Next one. In a first order reaction, the initial concentration of reactant was m by 10. After 8 minutes and 20 seconds, the concentration becomes m by 100. What is the rate constant? Now, the formula, this is the first order reaction, right? What is the formula for first order reaction? K is equal to 2.303 T into log of initial concentration, right? Log of initial concentration divided by concentration at time T, AT, right? That is our formula. So is equal to 2.303 T. T is what? Time in second. 8 minutes and 20 seconds. 8 minutes means 8 into 60 seconds. 800. 8 6 are 48. So 480 plus 20, you got 500 seconds, right? So 2.303 divided by 500 into log of A0 by 80. A0 what? Initial concentration. What was the initial concentration? M by 10. That means 1 by 10, right? 1 by 10 divided by 1 by 100. So how can we calculate this? 2.303 divided by 500 into log of, what is 1 by 10? 1 by 10 is 0.1. What is 1 by 100? 0.01. So basically it becomes 10 raised to minus 1 divided by 10 raised to minus 2, right? 10 raised to minus 2 on going up becomes what? 10 raised to minus 1, 10 raised to plus 2 is equal to 10 raised to plus 1. So therefore this becomes 2.303 upon 500 into log of 10 raised to 1, which is 10. And log of 10 is equal to how much? It's 1, right? So therefore your K becomes 2.303 divided by 500. Now we need to calculate it, obviously. 2303 into 10 raised to minus 3 divided by 500. 500 was the 200, sorry, 2000. We are remain with 3030, 4.56 the 300, sorry, 3000 again 30. But anyways, we got our answer 4.6 into 10 raised to minus 3. And which answer is most closest to it? 4.6 10 raised to minus 3, D. So option D is our correct answer in this case. That is how you can solve such questions. It is not that difficult, I know. You will find it easy also. Okay. I hope you are clear with this. If you have any doubt, you can ask me in the comment section. Okay. Do not hesitate to ask me anything. You can ask me in the comment section always. Okay. So now moving ahead. Now you have got the answer here. So let's move ahead with the next question. I'll tell you the answer of this is D. I told you the way we have solved it. Okay. But I need a space for the next question. That is why I erased all the data. Next, substance A reacts according to first order rate law. Substance A reacts according to first order rate law, which gave us K equal to 5 into 10 raised to minus 5 per second. Okay, that was your A. If the initial concentration of A is 1 molar, if the initial concentration of A is 1 molar, then initial rate is how much? Now A reacts according to first order rate law with K is given. Okay, so K is equal to 2.303 divided by T, right, into log of initial concentration of A is given. The initial rate is see this here, it is quite simple. Rate is equal to K. It's a first order, right? So R is equal to A raised to 1. So what they're asking is the rate. What is K? K is 5 into 10 raised to minus 5, right? And concentration of A is what? It's 1 molar. So it's quite simple. Rate is equal to 5 into 10 raised to minus 5 into 1, which is equal to 5 into 10 raised to minus 5 only, which makes option B to be the correct answer. Okay. So that is how you can solve it. This question was a bit tricky. Okay. Initially, after reading this, it might confuse you. But if you look at it closely, you will understand that it is not that difficult as it was appears to be. Okay. So moving ahead with this. Dinitrogen pentoxide, which is this 2N2O5, decomposes to give you 4NO2 plus O2. The rate can be given in 3 ways. Decrease in concentration of N2O5 is equal to K N2O5. Increase in concentration of DNO2 is equal to K2N2O5. And increase in concentration of DNO2, actually it is not DNO2, it has to be O2. Actually it has to be O2. Must be O2 is equal to, because there are one reactant, 2 product, right? So one reactant and other 2 products we have already got. So what was remaining is DO2 divided by dt is equal to K3N2O5. What that's saying is, what is the relationship between K1, K2 and K3? Okay, first write the rate in terms of every species. So rate in terms of N2O5 is equal to minus 1 by 2 d of N2O5 dt, right? Then is equal to plus 1 by 4 change in a concentration of NO2 divided by dt is equal to plus change in concentration of DO2 divided by dt, right? Now D on N2O5, this DN2O5 is given is equal to K1N2O5, right? Is equal to KN2O5. So rate is equal to basically what I would say KN2O5 divided by 2, right? Because 2 is right here, is equal to again dNO2 by dt. dNO2 by dt is equal to what? K2N2O5. So putting that value here, what do we get? K2N2O5 divided by 4. is equal to DO2. DO2 by dt is again given K3N2O5. It is right, K3N2O5. That's it. So dividing all of this, rather I would say dividing all the equation. Now we need to equate them, right? We need to equate them because we need to find out the relationship between them. So to equate them, we need to divide all of them. So dividing all the equations by a concentration of, what is common factor here? N2O5. What do we get? R is equal to K1 by 2 is equal to K2 by 4 is equal to K3. Okay, then what do we get here? What is the relationship? See, you can see here. If you send 4 to this side, what do we get? If you send 4 to this side, what do you get? 4 into K1 divided by 2 is equal to K2. So that means K2 is equal to 2K1. You can see here. K2 is equal to 2K1 and K1 by 2 is equal to K3. Therefore, rather K3 is equal to 1 by 2 K1. It is right in front of you. So K3 is equal to 1 by 2 K1 and K2 is equal to 2 K1. Which options are belonging to this? Take a look at it. Yeah, the very first option where you can see K2 is equal to 2 K1 and K3 is equal to half K1, which makes option A to be the correct answer for this. That is why this is the right answer for this. Okay. So moving ahead with this, the half-life period. The half-life period for a reaction at initial concentration of 0.5 and 1 mole are 200 second and 100 second respectively. Then the order of the reaction is. We all know that T half is inversely proportional to A raised to n minus. What is A here? A is your initial concentration. Okay, I'm telling you this formula. I hope you are already known with this formula, right? So T half is directly proportional to A raised to n minus 1. Okay, now we got two T half. One is of 200 second, one is of 100 second. Okay, so we need to take a ratio of those. Taking ratio, right? What do we get? 200 wala T half divided by 100 wala T half. Okay, I'm just telling you. Now 200 wala is inversely proportional, no? So the 1 will come over here and 2 will come over here, raised to n minus 1. Right? Am I going wrong way? 200.5. Yes, right. 200, maybe just a sec, let me calculate it. 2 by 1 is equal to, yes. Reversing this, what do we get? 2 by 1, 1 minus n. 1 minus n. What do we get? So 2, let me solve it on this side. 2 is equal to 2 raised to 1 minus n. Now 2 is equal to, that means 2 raised to 1, right? 2 raised to 1. So 1 is equal to 1 minus n. And therefore sending n on that side, n is equal to 1 plus 1 and n is equal to, and that is why your n is 2. That means this reaction is of second order, and therefore option C is the correct answer for this. Okay, I hope you must have cleared this. You must have understood this. If you have any doubt, you can ask me in the comment section. Okay, see, T half is inversely proportional to the initial concentration, so I put those values T half of 200 divided by T half of 100. Now, since they are inversely proportional, the concentration for 200 wala T half comes here, right? Which was what? Which was a 0.1 divided by 0.5, nothing but what? It's a 2 only. Okay, that is why we have reached with the this answer. Okay, so I hope you are clear with this. Now, moving ahead with the next question. The slope of the line for the graph of log of K versus 1 by T for the reaction N2O5 gives you 2NO2 plus half O2 is minus 5000 calorie, sorry, minus 5000. Calculate the energy of activation of the for the reaction in kilojoule per mole. Now you might know the formula. K is equal to A E raised to minus EA by RT, right? Taking logarithm of both sides, what we get? Log of K is equal to log of, rather I would put the value of minus EA by RT plus log of A. Okay, obviously we have a 2.303 here, but I just ignore that, we don't need it. So log of K versus 1 by T, you can see here log of K versus 1 by T. So this is Y, 1 by T is your X, then minus EA by R plus C. So minus EA by R is your M. So this is basically Y is equal to MX plus C equation, which is the straight line equation. M is equal to what? Slope. Okay, and they have given the value for slope minus 5000. So from that you can calculate, right? Your M is equal to slope is equal to minus EA by R, and value of slope is given, it's minus 5000. So minus 5000 is equal to minus EA by R, right? EA by R. And what they have asked us to find out? The energy of activation, right? So how can we get the EA? The EA is equal to minus 5000 into R. What is the value of R here? Yeah, it is 5000 value of R. It's a kilojoule per mole, right? So value of R is 8.31. It is equal to 8.314. So your EA is equal to 5 into 10 raised to 3 into 8.314, right? Now calculating it, 8.314 into 5, 5 4s are 20, 0, 2, 5 1s are 5 plus 2, 7, 5 3s are 15 plus 5, 1, 5 8s are 40, 40 plus 1, 41. 41,500. Oh, did we make any mistake here? Minus EA by R, just a sec. Just 1 by T minus EA by R. R is in joule. It becomes 41,570. So dividing by 1000, we get what? 41.57 kilojoule. And we don't have that option here. Just a sec. Let me see what have gone wrong, or if the options are wrong, we don't know. So Y is equal to log of K versus 1 by T. Yeah, 1 by T minus EA by R. EA by R is equal to your slope, which is M, is given. Energy of activation for the reaction, kilojoule per Kelvin per mole. So kilojoule, Sarita Kancharla. Yeah. So answer for this is actually coming out to be 41.57 kilojoule, which we just calculated, right? So it should be none of this. Okay. But anyways, that is the way to solve it. Okay. By taking this equation, K is equal to A raised to minus A upon RT. You can take logarithm of both sides. By taking logarithm, you can find out what is the value of your slope, and whatever value they have given, you can equate it with, you can calculate the energy of activation or any other value for that matter. Okay, so moving ahead. For a reaction, the rate constant is expressed as K is equal to AE raised to minus EA upon RT. The energy of activation is, now we just solved this equation. K is equal to AE raised to minus EA upon R divided by T, right? So minus E raised to minus EA upon R. That value is how much? That value is 4000, we just saw. Minus EA by R is equal to, not 4000 actually, 40,000. It is 40,000, right? So they have given all the options in calorie, right? So we need to take R into the calorie. When you take R into the calorie, its value is how much? Its value is 2. In calorie, R is equal to 2. And therefore, energy of activation is 40,000 into 2. It becomes 80,000. It is 80,000. So what is our answer? 80,000 calorie. 80,000 calorie is our answer, which makes option C to be the correct answer. Okay, that's the way you can solve this kind of questions. Okay, so moving ahead with this. For a chemical reaction, A plus 3B gives you product. A plus 3B gives you product. It was observed that the rate of reaction increases. The rate of reaction increases 9 times. The rate of reaction increases 9 times when concentration of B increases 3 times. So we don't know whether reaction is dependent on A or not. But as far as B is concerned, we came to know just now that it is dependent on the concentration of B. So B raised to N. Okay. Now what they're saying, it was observed that rate of reaction increases 9 times. So this is K. Okay. This K becomes 9K when this concentration of B was increasing by a factor of 3. So this becomes 3B, right? This has thrice, rate has become 9 times. Equation 1, equation 2. How can we calculate the value of N? See, 9K divided by K is equal to 3B divided by B, right? This B raised to what? B raised to N, right? B raised to, or I would rather say, yeah, 3B raised to N. So K gets cancelled. You get 9 is equal to 3 raised to N. So 9 is equal to 3 raised to N. That means this must be square of 3, right? Square of 3, therefore N must be equal to 2. So as far as B is concerned, reaction is second order with respect to B. Okay. You just saw how can we calculate that. Now, after that, what are they saying? What are they saying? That on doubling the concentration of both rate, on doubling the concentration of both, rate increases 8 times. Rate increases 8 times. Then differential rate equation can be given as. Now, as far as the whole rate constant is concerned, we know that for B, for A, suppose it is M, and for B, it is 2. We just calculated it, right? For B, it's 2. So what are they saying? On doubling the concentration of both, rate increases 8 times. That means if you double the concentration, it becomes 8K. It is what? 2A raised to M. It is 2B square. Okay. Then what do we get now? 8K is equal to 2A raised to M is equal to 2B 4 square. Okay. So it is 8 is equal to 8 raised to m, which means m has to be 1. So that means this reaction is first order with respect to A. It is second order with respect to B. And therefore, the correct option here has to be B. You can see here. It is second with respect to B, first order with respect to A. And that is why in this case, our answer is B. Okay. That is the way by which you can solve this order based questions. Okay. Sure. Moving ahead. A reaction is second order. A reaction is second order with respect to reactant. Reaction is second order with respect to reactant if the concentration of reactant is doubled. Now this is quite easy for us because we have solved numerous questions based on such a type of genre. A reaction is second order with respect to reactant if the concentration of reactant is doubled. The rate of reaction should become 4 times. How? Because K is equal to whatever reactant, suppose your reactant is A, R is equal to K into A raised to N, right? Suppose your reactant is N. So what are they saying? If the concentration of reactant is doubled, so you have K 2A raised to N, okay? Then the rate of reaction should become what? So this N to be, if you want this N to be 2, what do you want? We don't know what it is, okay? So let's suppose this is कोई value है x की या nr है suppose, ठीक है? तो not n, हमको कोई और लेना पड़ेगा, x लेना पड़ेगा. चलो, so xr divided by r is equal to k 2a raised to n divided by k a raised to n. So k gets cancelled, a gets cancelled, r gets cancelled. X is equal to 2 raised to n, right? That is what we came to conclusion. Now this reaction is second order. For second order, n is equal to how much? 2. So x is equal to 2 raised to 2. And 2 raised to 2 is how much? That is why when the reaction is second order with respect to reactant, if the concentration of reactant is double, the rate of reaction should become 4 times. That is why in this case, the answer has to be C, 4 times. Okay. I hope it must have been pretty much clear to you. So moving ahead with this. The reaction 2A plus B plus C gives you D plus 2E is found to follow the rate law. What is rate law? A, B square, C 0. If the concentration of A, B, C increases 2 times, then rate of reaction should become what? See, R is equal to K, A, B square, C raised to 0. Now you know that any species raised to 0 is equal to 1. So C raised to 0 is equal to 1. So C has no concern there basically. So this is our basically first equation. R is equal to K A B square. That is equation number 1. What does say? If the concentration increases by 2 times, that means R should become now 2R. K is equal to, what does say? Oh, sorry, my bad. We don't know what it is here. What are they saying? If the concentration of A, B, C increases by 2 times, so A is now 2A, B is now 2B square. Then the rate of reaction becomes what? This is equation number 2. Okay. It could be whatever. Suppose if it is a XR maybe. Yeah. So XR divided by R is equal to K 2A 2B square divided by K A B right? K gets cancelled, RR gets cancelled, A gets cancelled, BB gets cancelled. What do we get? X is equal to 2 into 2 square. What is 2 square? 4. 4 into 2 is equal to 8. That means if in this equation, if we increase the concentration of A, if we twice the concentration of all the species, the rate of reaction should increase by 8 times. And that is why, and that is how in this case, the answer for this is option number C. Okay, that is the way you can calculate all of these questions. Okay, so moving ahead. Next, the following results. The following results have been obtained during the kinetic studies of the reaction. 2A plus B gives us C plus D. Okay. Now they have given us the experiment. You can see here experiment. There are 4 experiments which they have performed. Concentration of A are given in all those 4 experiments. Concentration of B are given, and the initial rates of formation of D. Initial rates of formation of D are given. So the rate law and the rate constant for this particular reaction is. Now see, whenever these people perform such a kind of experiments to check the dependence of rate of reaction on each concentration term. Now you don't know how many concentration terms are here. Here we can see there are 2 concentration terms. A is there, B is there. So if you want to check the concentration, if you want to check whether the rate of reaction is dependent on concentration of A or not, then you need to select those experiments where concentration of B is constant, but the concentration of A is changing. Okay. Similarly, when you want to check the dependence of rate of reaction on the concentration of B, then what you need to do? You need to keep the concentration of A constant in that case, and you need to change the concentration of B, so that you would see by changing the concentration of B how the rate of reaction is getting changed, so that you can find out its dependence on the rate of reaction. Okay. I hope you must be clear with this. As far as to find out whether the rate is dependent on the concentration of A or not, what do? We select those experiments where concentration of B is constant. And what are those experiments? First and second, you can see here. To check the rate dependence, on of A, we are selecting experiments first and fourth. Okay, by taking the ratio of them. How can we do that? Experiment number 4, concentration of B, concentration of A, concentration of B, concentration of A. Rate of reaction for fourth experiment, it is how much? 2.40 10 raised to minus 2 divided by 6 into 10 raised to minus 3. B gets cancelled because value is same, right? Now we don't know for what A is. So for A, let's take the value as maybe M. Okay. Because we don't know what it is. Okay. A. What is the value of A? For this experiment, it's 0.4. For this is 0.1, right? So 0.4 divided by 0.1 raised to M is equal to, you can convert this 2.4 into 24 into 10 raised to minus 3 divided by 6 into 10 raised to minus 3. Minus 3 gets cancelled. 0.4 divided by 0.1 has to be 4. 4 raised to M is equal to 4. So 4 raised to M is equal to 4. That means this value of M should be equal to 1. Exponent, no. 4 raised to M is equal to 4. So value of exponent has to be 1. So as far as this reaction is concerned, with respect to A, it's first order. Okay. So that is how you calculated it for the A. Now for the B. For B, you need to check or you need to select those experiments where concentration of A is constant. If you look at all these experiments, the concentration of A is constant in equation 2 and 3, right? So taking those experiments, taking the ratio of 3 as to 2, what do we get? Again, concentration of A, concentration of B, concentration of A 0.3 divided by 0.3 into 0.4 divided by 0.2 is equal to 2.88 into 10 raised to minus 1 divided by 7.2 into 10 raised to minus 2. 0.3 gets cancelled. 0.4 divided by 0.2 is equal to 2 is equal to 2.88 can be 28.8 into 10 raised to minus 2 divided by 7.2 into 10 raised to minus 2. 2 raised to n. Okay, this was m, this is m. 10 raised to minus 2 gets cancelled. 7.2 and 28.8. The relationship between them has to be 7 4s are 28. 0.2 into 4, 0.8. So 2 raised to n is equal to, and 2 raised to n is equal to 4 is only possible when you have n is equal to 2. So therefore, as order is concerned, with respect to A, it's first order. With respect to B, it's second order. So it is AB square. So your rate equation becomes R is equal to K AB square. So R is equal to KAB square is present in two equations. It is not present in D. So D goes. It is not present in B. So B also goes. What remains is A and C. Okay. Now to check the value of your rate equation, rate law and rate constant, they are asking here the rate constant. Okay. How can we calculate it now? The rate constant K is equal to rate upon concentration of A divided by B square. Okay. So what is rate? You can take any experiment for that matter. Let's suppose we take the first experiment. First experiment is 6 into 10 raised to minus 3, right? Which is rate. R is A and B square. What is A? 0.1, 10 raised to minus 1, right? What is B? That is also 0.1, 10 raised to minus 1 bracket square, which makes your K is equal to 6 into 10 raised to minus 3. 10 raised to minus 1 remains as it is. 10 raised to minus 1 bracket square, 10 raised to minus 2. So that makes K is equal to 6 into 10 raised to minus 3. 10 raised to minus 2 into 10 raised to minus 1, 10 raised to minus 3. 10 raised to minus 3 minus 3 gets cancelled. K is equal to 6. And therefore, as far as this case is, this question is concerned, the option A has to be the correct answer. C can't, because it is 6 mole, 6 per mole per minute. Mole per liter, no, it is mole per liter. So per mole per minute. The concentration has gone down, but let me tell you one more point. This concentration, which concentration? Which I wrote as 10 raised to minus 1 and 10 raised to minus 2. That is nothing but mole per liter raised to 3. Okay. And you have mole per liter in the numerator. So this become mole cube per liter. Then you have per liter at the top, which makes it mole raised to minus 2 per minute. That makes option C to be correct answer. See how subtle the difference was here. See, everything was same here. K, rate constant R, rate equation R is equal to K, A raised to 1, B raised to 2. And in both option A and C, it was K, A raised to 1, B square. You can see it here. Then the rate constant was also 6 in both the cases. Only difference was per mole square, and it has to be per mole square here. Okay, as far as rate constant rate equation becomes, and that is why the answer is C. It is not A. Okay, so beware of such subtle differences. This might trap you, and you might get -1 mark in that case. Okay, not even -1, actually -5. This 4 also goes, and -1 goes from the questions which were right. that you attempted. Okay, so moving ahead. Next, for the reaction, R gives you P. The concentration of reactant changes from 0.03 to zero point zero 0.02 in 25 minutes. The average rate in seconds is. The average rate in seconds is. How do we calculate the average rate? Average rate is 0.03 minus 0.02. Rate change in concentration divided by time, 25 minutes or second, whatever you need to take. So 0.03 divided minus 0.02 is equal to 0.01 divided by 21, which is equal to 100 into 10 raised to minus 4 divided by 25 is equal to 4 into 10 raised to minus 4 mole per minute, because we took the minutes only, right? 25 minutes, which makes option B to be the correct answer in this case, right? These are the ways by which you can solve such questions. Okay, moving ahead with that. Next, from the following data for the reaction between A and B, A are given, B are given, initial rates are given. The order of the reaction with respect to A and with respect to B is. Now we have solved such question earlier also. Okay, we just solved this question of this type couple of slides ago. Okay, so I am going to tell you only the thing. I'm going to tell you the only the thing which will help you get your answer immediately. Okay, let's see. When B goes from here to here, see the concentration of B is constant. The concentration of B is constant. That means we need to check the concentration of A only. Okay. Anyways, we need to take the ratio. We need to take this ratio. You go by anyway. So this is equation number 1, 2, 3. How can we do this? We need to, as I told you earlier, we need to take those experiments where concentration of B is constant, because if you want to find out the dependence on A, you need to keep the B constant. If you want to find out the dependence on B, you need to keep A constant. In this particular case, we are finding out the dependence on A. Therefore, we need to keep B constant. B is constant in experiments 2 and 3. So taking the ratio of experiments 3 and 2, what do we get? 1.0 into 10 raised to minus 3 divided by 5.0 into 10 raised to minus 4 is equal to, this is your A, right, is equal to 1.6 into 10 raised to minus 2 divided by 4 into 10 raised to minus 3. So converting this 1.0 into 10 into 10 raised to minus 4 divided by 5 into 10 raised to minus 4. This is equal to 16 into 10 raised to minus 3 and 4 into 10 raised to minus 3. Minus 4, minus 4, minus 3, minus 3 gets cancelled. 10 divided by 5 is equal to 2. 2 raised to m is equal to 2 raised to m is equal to 4. This is only possible when your m is 2. That means as far as A is concerned, reaction is second order. So with respect to A, it's a second order. Okay. So what they're asking, the order of reaction with respect to A and B respectively are A and B. So A is 2. We don't know what B is. So here A has given it to be 1. This can't be our answer. Here A is given to be 1. This also can't be our answer. Our answer can be either A or it could be C. Okay. That is how you can nullify the options which are not possible. Okay. Now let's see what happens with respect to B. Now we know that it is second order with respect to A. So we can write our equation, that constant R is equal to K A square B raised to N. We don't know what it is. Again, to check it, what do we need to do? We need to take the ratio. Now there is no equation here where A is constant. There is no equation where A is constant, but we don't need that now. We got that for A it is second order. So let's keep it and let's take the B. Okay. So let's take equation 1 and 2 where B is changing. We need to take the equation where B is changing. Okay. But now A is also changing. We can't help that. So taking the ratio of equation 2 and 1. Taking the ratio of equation 2 and 1, what do we get? Let's write it. For equation number 2, 4 into 10 raised to minus 3 divided by 5 into 10 raised to minus 4 is equal to 6 into 10 raised to minus 5. That is our B for this. A, 5 into 10 raised to minus 4 divided by, again what is B? 3 into 10 raised to minus 5 divided by 2.5 into 10 raised to minus 4, right? 10 raised to minus 4 gets cancelled. Minus 5 gets cancelled. 4 into 10 raised to minus 3 can be written as 40 into 10 raised to minus 4 divided by 5 into 10 raised to minus 4. It is equal to what? 6 into 5, 30. 2.5 into 3, 7.5. Rather, 2.5 into 2 is 5. 3 ones are 3, 3 twos are 6. 2 into 2, 4. 10 raised to minus 4, 10 raised to minus 4 gets cancelled, right? Then what do we have? 5 raised to 40, 8. So your 8 is equal to 4 raised to n. One more thing, the concentration of A has to be square here, no? It has to be square. So more, sorry, my bad. So let me have some space here. Yeah. So this is 8. We know that this is 8 on this side. And what do we have is 6 into 10 raised to 6 into 10 raised to minus 5 into 25 into 10 raised to minus 8. For A, it is becoming square, right? Then we got what? 3 into 10 raised to minus 5. 2.5 square becomes how much? 6.25, right? 6.25 into 10 raised to minus 8. 10 raised to minus 8 gets cancelled. Minus 5 gets cancelled. 8 is equal to 6.25, 25. This is 4, 3, 4 into 2, 8. Yeah. So it is 8 raised to n. 8 raised to n, therefore your exponent n has to be 1. That means this reaction is second order with respect to A, first order with respect to B. And the option which is suitable for that is A. And that is why A should be our answer in this case. It can't be C. Okay. I hope this must have been helpful for you. If you really find this helpful, please do like it, comment on the video, and please subscribe to Practically also. Okay. So that is why answer is A. Now next, a first order reaction takes 40 minutes for 30% decomposition. The T half for the reactions. Now T half is equal to 0.693 upon K. Okay, they're asking T half only. The first order reaction takes 30 minutes, 40 minutes for 30% decomposition. Okay, so how can we calculate this now? As far as this K is concerned, 2.303 upon T log of, we need to get the K first. By putting the value of K here, you can get the T half. Okay, 2.303. And how can we get the K? K is equal to 2.303 upon T log of initial concentration divided by concentration at time T. So they are saying 30% decomposition. That means 30% has got decomposed. What is remained is 70%. But initially it has to be 100, right? 100 minus 30, it is 70 now. So K is equal to 2.303. 2.303 divided by 40. Now we need to take this in what? T half okay, T half will also be measured in minutes then. 40 log of 100 minus log of 70. K is equal to 2.303 upon 40 into log of 100 is how much? 2, right? Because 100 is what? 10 raised to 2. And log 70 is how much? Let me tell you the trick for log values of different number. 0 to 10 I mean to say. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For 1, it's 0. Okay. Log of 2 is 0 0.30. Log of 3 is 0 0.47. Log of 4 is 0 0.60. Log of 5 is 0 0.69. Log of 6 is 0 0.77. Log of 7 is 0 0.84. Log of 8 is 0 0.90. Log of 9 is 0 0.95. And log of 10 is 1. So you might say, sir, how do you remember all of this? Now, I don't remember all of this. I remember only one value, which is, in fact, 2, 3 value. Log 1 is 0. Everyone knows that. Log 10 is 1. You also know that. I remember the value of log 2. Log 2 is 0 0.30. Okay. Let me show you how is the trick to remember this. See, when you come to know that log 2 is 0 0.30, then what is the value of next log, which is log 3? Just increase it by a 0.17. Let's consider 17 only. Okay. Just increase it by 17. See, 0.17. Then next is this gap is of 17. Next gap is 13. See, 17, 13. Are you recognizing the pattern? 60, 69, 9. Do you get the pattern here? Difference between log 2 and log 3 is of 0.17. Difference between log 4 and log 3 is 0.13. Difference between log 5 and log 4 is 9. So the first difference is 17. Decrease it by 4, 13. Decrease it by 4, 9. Now that you have got the difference of time, now you have a difference of only 1. How? 6.9 to 77, difference is of 8. 77 to 84, difference is 7. 84 to 90, difference is 6. 90 to 95, difference is 5. And again, lastly, 5. That you don't need to remember. Okay, that's how you can remember the different log values. Okay, so from this, how much log 7 is? Okay, we can take it 10 by 7. Log 10 by log 7. Log 10 is 1, right? Log 7 is how much? 0 0.84. So basically your K is 0 0.303 upon 40. 1 minus 0.84. 1 minus 0.84 is 0.16, right? Then what is your K now? Okay, we are yet to calculate this. 2.303 into 16 into 10 raised to minus 2. That becomes 16 3s are 48, 8, 4. 16 0, 16 into 0, 0. We get a 4. 16 3s are 48, 8, 4. 16 2s are 32 plus 4, 36. 1, 2, 3, 4, 5. 0 0.36. K is equal to 0 0.36848 divided by 40. So let's make it K is equal to 3.68 divided by 4. Okay, I just change the decimal. K is equal to 3.68 divided by 4. 4 9 are 36, 8, 0.92 basically. So T half is equal to 0.693 upon 0.92. 0.693 upon 0.92. T half is equal to how much it becomes? 69.3 1.3 upon 92. It must be some minutes. Maybe have we gone the wrong way? I don't know. First order. But anyways, that is how you can solve this. Okay. We are short of time, so we need to move ahead because we need to cover one more chapter. And that is biomolecules. Okay. Let's go to that. Biomolecules. So nanopeptide. The very first question for is nanopeptide. What is meant by nano? Nano is 10 raised to minus 9. We know that 10 raised to minus 9 meter. Here nanopeptide means 9 peptide series. 9 peptide series, and 9 peptide series will always have 8 peptide linkages. What is peptide linkages? CONH is called as peptide linkages. So if the nano is there, it has to be 8 peptide linkages, just like that. Okay. Transfer RNA. Transfer RNA anticodon for the messenger RNA codon GCA is. Now, as far as this is concerned, ACTG, see, G can replace C. G can be replaced by C. C can be replaced by G. And A can be replaced by U, which makes this CGU. Where is it CGU? CGU is here. That is why the answer in this case is third. Okay, that is how you can solve this RNA anticodon problem. Next, the minimum number of carbon atoms that should be present in monosaccharide is. The minimum number of carbon atoms that should be present in monosaccharide is how much? It should be at least 2. It should be at least 2. How? One will be your aldehydic or ketonic group, other will be hydroxyl. It should be containing at least 2 carbon atoms. Next, carbohydrates that on attempted hydrolysis are not cleaved. Carbohydrates that on attempted hydrolysis are not cleaved to smaller carbohydrates are called as what? So carbohydrates that on attempted hydrolysis are not cleaved to smaller carbohydrates are monosaccharides, right? Because oligosaccharides, disaccharides will give you 2 monosaccharides on hydrolysis. Oligosaccharides will give you 3 to 5 monosaccharides on hydrolysis. Polysaccharides will give you many, I would say more than 10 monosaccharides. So monosaccharide is the most basic unit of it. And therefore monosaccharides can't be cleaved by hydrolysis or by any method for that matter. Okay. Next, IUPAC name of Keto Trios is. What is Keto Trios? C double bond O. See, this is CH2OH, C double bond O, COH, H. This is our Keto Trios. Keto Trios. What is it? You can see it is just like acetone. C double bond. This is acetone, right? Acetone's IUPAC name is what? Propanol, right? But instead of having CH3, they got the OH here. OH. And we call that as trios. Tri stands for 3 carbon atoms. And O is the general name for them. So 3 keto trios. What is the name of this? 1, 2, 3. 1, 3 dihydroxy oxypropanol. 1, 3 dihydroxypropanol. Right? 1, 3 dihydroxypropanol. That should be its IUPAC name. That's how you can solve this kind of question. Okay. So moving ahead with this. The number of chiral centers. The number of chiral centers in the open chain structure of glucose is. Open chain structure. What is the open chain structure? This is glucose. C double bond O H, C H O H, right? COH H, COH H COH H CH2OH. So this is not a chiral carbon. This is not a chiral carbon. Chiral carbon is where 1, 2, 3. All of these four are chiral carbon. Therefore, the number of chiral centers in the open chain structure of glucose are 4. Therefore, option B is our correct answer in this case. Okay. Cane sugar. Cane sugar on hydrolysis gives what? Cane sugar is what? It's a sucrose. C12H22O11 plus H2 in presence of H plus ion. It gives you what? 2 units of C6H12O6. One is glucose and another is fructose. So you get of glucose plus fructose as far as cane sugar is concerned. And what are glucose and fructose to each other? See, the structure which I draw is just like your fructose only. Only difference is that in fructose you have a CH2OH and you have a ketonic group here. You have a ketonic group. In glucose you have aldehydic group. So their molecular formula is exactly same. What is it? C6H12O6. But the functional groups are different. Functional group for fructose is ketone. Functional group for glucose is aldehyde. And what aldehyde and ketones are? They are functional isomers. They are functional isomers of each other. And what is functional isomer? These are the compounds which are having same molecular formula but different functional groups. Okay. So, moving ahead. Freshly prepared solution of cane sugar. Freshly prepared solution of cane sugar under the influence of an acid catalyst. Freshly prepared solution of cane sugar under the influence of an acid catalyst undergoes change in an optical rotation. Change in an optical rotation with lapse of time. This phenomenon is called as, what do we call that phenomenon as? Inversion. It is inversion. Okay. Many of these are memory based question. Okay. But obviously we need to remember them. We don't have any other option. Glucose gives a positive silver mirror taste with ammoniacal silver nitrate because it contains, see, positive silver mirror taste, that means tolerance reagent. So the only those compounds which gives tolerance reagent positive are aldehydes. Okay. And there is one more, I'll tell you that. So as far as glucose is concerned, glucose gives positive tolerance reagent taste because it has aldehydic group in it. Lastly, fructose. Fructose reduced failing solution due to presence of fructose has, so this is the fructose, CH2OH, C double bond O. Then you have a CH, OH, OH, H. The other structure you already know. So this is your ketonic group and this is your alpha carbon, right? So it has alpha hydroxy ketonic group and alpha hydroxy ketonic group and other aldehydic group. They give the failing solution. They reduces the failing solution. Okay, that is why the answer for this question has to be D. Okay, so moving ahead. Plus sugar, sucrose is made up of what? Plus means what? Plus indicates D and minus indicates L. Okay, that is the common name system. So sucrose, we know that sucrose on hydrolysis gives what? Sucrose on hydrolysis gives glucose and fructose. And since it's a plus, that means D, therefore it should be made up of D-glucose and D-fructose. And that is why our answer in this case is B. Nextly, glucose cannot be classified as. Glucose is a carbohydrate, we know that. Glucose is a hexose, right? And aldohexose to be precise. It's an aldose, right? Oligosaccharide? No, it is not oligosaccharide. It's a monosaccharide. Okay, because that is not how you can classify the glucose is. Okay, so that's it for this session. Thank you very much for being patient with me. Okay, I hope you really enjoyed this session. If you really do, please like, comment, and subscribe to Practically on YouTube. Okay. And if you really want us to bring more such interesting courses for you, so that you will be able to crack the dream exam of yours, please subscribe to Practically on YouTube. You can also download our app from a Play Store and from Apple Store. You can log into it. We have a various different courses for you. For example, we have courses in Vedic maths, coding, chess, robotics. Okay. You will really enjoy. You will really enjoy it, I promise, by exploring those courses. Okay, but for that you need to download our app. You can log into it. Okay, we are providing all these courses in a audio visual format. That means you will really enjoy having the videos of that. Okay, that in that way you will enjoy it. I mean, you will learn it with the fun. Okay, so that's it for today's session. Bye bye from my side.